Hi everyone, in this video I would like to discuss today's biweekly contest, that is biweekly contest 186. So let's start with the first problem. Our first problem is unique middle element, and in this problem you are given an integer array nums of odd length n, and you need to return true if the middle element of nums appears exactly once in the array, otherwise you need to return false. Okay, so this is pretty simple problem. We just need to check whether the middle element appears only once or more than once. So just implement it. Let's find the length. So length of this given array nums. Okay, now let's check in. So one way is you can create an unordered map, right? And you can insert the frequency, right? And you can finally you will check that the frequency of middle element is equals to 1, then you will return 1, then you will return true, otherwise you will return false. And this will take order of n space, right? So to improve the space, you can also solve this problem in order of 1 space, right? So how you will do this? You will just check if I is not equals to the middle index and nums of I is equals to the middle element, that is n by 2. In this case, you know that the middle element appears at some index I which is not equal to middle index, right? In this case, you know that middle element appeared more than once, so you will return false, otherwise you will return true. So we have just solved it in order of n time and order of 1 space. So let's run the sample test cases. First is true, second is false. Great, so let's submit it. Great, let's move to the next problem. Our next problem is maximum valid pair sum. So you are given an integer array nums of length n and integer k. A pair of indices I, j is called valid if j is greater than I and j minus I, that is the difference between j minus I, is greater than or equals to k, right? In this case, you need to return the maximum value of nums of I plus nums of j among all valid pairs. So this problem is also pretty simple. What you need to do is you can iterate over every pair I comma j such that j minus I is greater than equals to k, and you can find its sum of this pair nums of I plus nums of j, and you can return the maximum over every I comma j which satisfies this condition, right? So this problem can be solved in order of n square time. So let's see if the limit allows. N is order of 10 to the power 5, so obviously our solution order of n square solution will not work here, so we will have to we need to optimize this, right? So how you can optimize it? The way you can optimize it is, let's say you will you can solve this problem with the help of sliding window, right? You will always keep a window of length k, right? And you each time you will slide your window by one position to the right, and here you will also keep a track of the maximum value of all integers before this first element of your window, right? So to visualize it, what I am saying is, let's say you are given this array a1, a2, a3, a4, a5, a6, a7, a8, right? So let's say you are given these elements, and what you will do is you will keep a window of length k. For now, let's say, for example, k is equals to 4. In this case, your first window will be from a1 to a5, right? Here your first element is a1, so you will also keep a track of the maximum value. And what is this maximum value? Maximum value is all the elements including your first element before the which are lying before this first element of your window, right? So here in this case there is only one element, a1, and you will keep a answer variable which will store answer for the maximum sum of the pairs, right? So here for this window, what you will do is you will find a5 plus mx, right? This is your answer for this window. Now you will slide your window one position right. This is for the first case. For the second, let's say you moved your window by one position right. In this case, you will update your maximum variable, right? What is your maximum variable? Your maximum variable is maximum value of all elements lying behind this window, right? So what are all values? a1 we have already stored it, so in this case we will take maximum of mx comma a2, right? Because in our window this is a new element which is behind this or including this first element of the means starting of this window, right? So maximize this element, maximize this value mx, and again calculate the answer, right? Answer equals to maximum of answer comma a6, maximum answer comma mx plus a6, right? On the third iteration, what you will do is you will again move your one window by one position. In this case, again update your mx variable. What is mx? Mx is maximum value of all the elements behind this window, right? So in this case, mx comma a3, right? And again calculate answer. Answer equals to maximum of answer comma mx plus a7, right? So in this case you will keep on doing this until you reach your end point of your window at an. Okay, when your end point of your window will reach an, then you will calculate your answer and stop your loop. And when you will iterate your whole array means your window reaches an, at this case you had your answer, that is maximum value of sum of all pairs that satisfy this condition. What is the condition? J minus I should be greater than or equals to k. So this is how you can calculate your answer. So you understand, right, how is this how our solution is iterating over every pair which satisfies this condition, right? Because we are taking a window of size k, right? And we are only considering our end element, right? If we consider our end element, what are the possible values of I we can have? Possible values of I we can have is this, and this, right? Because j minus I must be greater than or equals to k, right? And we already know the maximum value of these. If you know if your j is fixed, okay, then can you tell me what you should optimally pick? as the index I, you will say that I will definitely pick the maximum value of AI, right? For a valid I, what is your valid I? J minus I should be greater than equals to K. So these are only valid I. You will pick maximum value among these, and this maximum value you already know, that is mx, right? So your answer will be for this particular J will be mx comma mx. Answer will be maximum of answer comma mx plus a of j, right? So this is how you can solve this problem using sliding window. So let's also implement it. This is the size of this array. Take a variable answer. Let's take a variable mx, right, and iterate over the sliding window. So your endpoint of your sliding window is right now k, and your sliding window currently is from index 0 to index k. Index 0 to index k. This is right now. First window is from 0 to k, right? Okay. And for any general I, your window is from I minus k to I, right? For any general I, this is your window you are considering right now. So let's update the maximum variable, mx variable. So your mx variable is updated to this. This is, what is this? N minus nums of I minus k. This is your starting value, means starting point of the window, right? As you have updated your mx variable, let's find the sum and eventually update your answer variable. So current sum will be nums of I, mx plus nums of I, and update your answer variable. At the end, just return answer variable. So for first, your answer is 13. For second sample test case, your answer is 14. Okay, let's go ahead and submit it. Great. So second we are done. Let's move to the third problem. This is our third problem. In this problem, you are given two binary arrays S1 and S2 of same length n. Great. So you can perform the following operations on S1 any number of times in any order. You need to choose index I such that S1 of I is 0 and change it to 1. Okay. Second type of operation you can make is you will choose index I such that I is between 0 to n minus 1, and both S1 of I and S1 of I plus 1 are 1, then you will change both characters to 0. You need to return the minimum number of operations required to make S1 equals to S2. If it is impossible to make S1 equals to S2, you will return minus 1. So the problem is simple. You are just given two binary arrays of same length. Now you can apply some number of operations of two kinds on S1 string. The first kind of operation you can apply is you can just pick one of the index, and if the index value is 0, then you can change it to 1. The second kind of operation you can apply is you will pick two consecutive indices I and I plus 1 such that both of the values of those indexes are equals to 1. Then you will change the value corresponding to both of these indices equals to 0. So these are the only two allowed operations. You at the end you need to find the minimum number of operations required to make S1 equals to S2. Otherwise, if it is impossible, you will just return minus 1. Okay, so let's solve this first sample. Okay, here you are given your S1 equals to 1 1, S2 equals to 0 0. So you can apply this first kind of operation. In first operation you will just apply the second kind of operation. This is pick two indices, one whose both values are equals to 1, you will change both equals to 0. So you can just pick these two indices 0 and 1, right? And you can apply second kind of operation. It will make both of these values equals to 0, right? So this is the, after applying first operation, this is the S1 you will have, and S2 will remain as it is. You do not need to apply any operations on S2, means you can't apply operations on S2, you can only apply operations on S1. So applying second kind of operation on S1 makes S1 equals to S2, right? So you are able to solve this problem in one operation, right? So this is your answer for first sample test case. Now think about how you can solve for a general array. Let's see the constraints. Constraints over S1 and S2 are 10 to power 5. So it is expecting us to solve this problem in order of n over n log n, something like this. Okay, so how you will solve this problem for a general S1 and general S2, right? So think about the kind of operations we can apply, right? Observe they change. The first operation, in first operation you will pick any index of S1, right? And if its value is 0, you will flip its value to 1, right? If it is 0, you will make it 1. This is the first kind of operation. Second kind of operation is you will pick two consecutive ones. You will pick two consecutive ones and change these two ones into 0, right? Now what do you see here, right? What do you see here? If there is, let's say, if there is any index I, right? If there is any index I whose value corresponding to S1 is 0 and corresponding to S2 is its value is 1, then it is very easy to change from 0 to 1. What you need to do is you just need to apply one operation of first kind, right? This is very easy. Now assume, now let's say if there is any index j, right? Think of it like this. Let's say there is any index j whose value is 1 in S1 and whose value corresponding to this index in S2 is 0. Now can you change its value from 1 to 0 in one operation? Is it possible? Yes, it is possible, but it is not always possible. Why? Because for this changing from 1 to 0, we cannot do this by applying first kind of operation. For this we will have to apply second kind of operation at least one time, right? Because changing from 1 to 0 is only possible through second kind of operation. So here in this case, what you will check is, for minimizing the number of operations, what you will check is, first you will check if there is 1 in either side of, let's say, j minus 1 and j plus 1. So you will check if there exists 1 in the neighborhood of this index j. Let's say this value is 0 and this value is 1. So, and this is 0. Okay, so you will see, for now, for the simplicity of understanding, let's assume this is also 0. Okay, now you see that if j plus 1 is 0, j plus 1 is 1 in S1, then what you can do is you can simply apply second kind of operation. In second kind of operation you will convert this to 0, this to 0, right? And you have applied one kind of operation, and then eventually you will again you will see that you need the final value of j plus 1 must be 1, right? So you will eventually apply the first kind of operation and you will change it to 1, right? And this also take one operation. So total you required two number of operations, right, to convert this particular 1 to 0. Okay, so now you see that to optimally solve this problem, we need to first convert all of the 1 into 0, right? By this what I mean is, first you will check in string s1, let's say you will check for all of the indices whose value is 1 in s1 and whose value is 0 in s2. So you now see that you need to change all of the values 1 into 0 and first try to change those values. Now once you are done with changing all of the 1 to zeros, now you will apply first kind of operation to all of the indices whose value is 0, right? Because changing from 0 to 1 always take one number of operation, right? And changing to changing from 1 to 0, it can take either one operation, two operation, or three operations, right? So let me elaborate it a bit more. So you understand first kind of operation, right? So for second kind of operation, we are just observing second kind of operation, right? Second kind of operation here, second kind of operation. So there, so let's think about the total number of possibilities we can have. J minus 1, j and j plus 1, these are the indices and their corresponding strings. Let's say their values 0 0 0 can be there, 0, this should be 1 because we are only observing for 1 1 0 0, and this is the one of the possibility. Another possibility is this one. Let's say this is 1 0 and this is your let's say for example 1 1 and 0 0. And for understanding, we only need one neighborhood element, right? Right, because the earlier one, j minus 1, we will also apply similar kind of operation. So we just need to understand one of the neighborhood element. So okay, 1 0, here in this case let's say 0 1, and the fourth possible case is s1 s2 1 0 0 1. So these are the only possible cases that we can have where we do need to convert 1 from 0 for the particular index j. So here in this case, find the total number of operations you will have to apply, right? So the total number of operations you will have to apply is, first you will have to convert this 0 to 1, right? For this case, apply first kind of operation and you will convert 0 to 1. It took one operation. Then again apply second kind of operation on these two indices, right? And the second kind of operation will convert this to 0 and this to 0. Now both of these are equal, so it needed total two number of operations. For this case, you can just apply second kind of operation on both of these indices, right? So only one operation needed to convert this to 0 and this equals to 0. Okay, and for this one s1 s2, first you will have to convert this 0 to 1 and then 1 to 0. So apply first kind of operation on this and then apply second kind of operation on both of these. So it also took total 2 number of operations. For this one, what do you need to do is apply first kind of operation, convert it to 1, and then apply second kind of operation on both of these indices. So it also took total 2 number of total 2 operations. So here you will see that in all of these cases, the value of this index is 0. This is 0, this is also 0, and this is also 0, right? And value of this is also 0, right? And now you know that, let's say if the corresponding S2 of j plus 1 is 1, now you can easily convert it from 0 to 1, right? How you can convert from 0 to 1? You can just apply first kind of operation. It will take total 1 operation. So converting from 0 to 1, you don't care. If they are not equal, you will just apply first kind of operation. But one of the interesting cases, if this is the possible, for this particular case, you only need one number of operation to convert it from 1 to 0. In all other cases, you need at least 2 operations. Why I say at least 2 operations? I say at least 2 operations because here in this case, these 2 elements are 0 0 after applying 2 operations, and these 2 elements are also 0 0. So you don't need to apply any extra operations. But think of this case, this one. Here you have converted this 0, this is 0, but this is these two are equals to 0, right? And this is finally 0, and this is 1. So you will have to apply one more operation, right, to make both of these equal. If you understand this case also, finally these two are 0 0 and this is 0 1. So you will have to apply one more operation to convert this 1 to 1. So if you see total number of operations, it took 3. And if you understand this case also, finally its value is 0 and its value is 1. So you will have to apply one more operation of first kind on this, and then both of these values will be equal. So total it took 2 operations. So you can see that first kind of operation took situation took total 2 operations to make both these indices equal to S2. It also took 2, it also took 3, and it also took 3. So by this, what do you understand is, you understand that there may be some favorable cases. For example, this kind of where do you see? Why did it take 110? I missed one of the case here. These two are identical actually, right? So let's make this 0 and find out their total number of operations. This was initially, let's say, 1, because 1 0 we haven't considered anywhere else. So let's find the total number of operations for this particular case. So for this particular case, what you did, you have both 1 1. So you will apply second kind of operations and convert both of these to 0. Also convert these to 0. So you needed one operation of second kind, right? Now you don't need to apply any other operation because both values are equal. So in total you needed only one operation. So you can see that there may be some favorable cases for applying second kind of operations in which you don't need to apply operation on the another neighboring index, right? For example, this one. So what does it imply is you will apply the number of operations, you will apply the second kind of operations on all of the indices first wherever it is required to convert 1 to 0, right? Then remaining elements will need, so for example there will be some number of zeros in index in string s1 which are needed to convert into 1. So for that you will just apply first kind of operation. So this is what you need to implement here in this third problem. So just implement this greedy algorithm. Let's take answer variable which will store the total number of operations we have applied till now, and this is the length of both of these arrays. I equals to 0, I less than n. Okay, so we are just reiterating, we are first trying to find if s1 of I equals to 1 and s1 of I not equals to s2 of I. So we need to convert 1 from 0. So we will check if I plus 1 is less than n. If I plus 1 is less than n, then we will check if s1 of I plus 1 equals to 0, right? If this is the case, if s1 of I plus 1 is 0, then we need to convert this 0 to 1 and then apply 0 to 1, applying first kind of operation, and then these both indices I and I plus 1 will be 1 comma 1. Then you will apply the second kind of operation to convert both of these elements to 0. So so it will take total 2 number of operations, right? And the final value of s and the final value of s1 of I, final value of s1 of I will be equals to 0 in all of the cases, because we are trying to just convert s1 of I from 1 to 0 because they both are not equal. And here in this case s1 of I plus 1 will remain 0 as it is because the final value will be 0. The else case is that its value is 1. If both of the corresponding elements si or s1 of I and s1 of I plus 1 are 1 1, then you will apply the second kind of operations, and applying second kind of operation you will convert s1 of I plus 1 equals to 0 because both of these both of these neighboring elements will be converted to 0, right? So another case is, else case is when you are looking at your previous element, right? Now you are looking at your previous element. If s1 of I minus 1 equals to 0, then you will do the same thing. You will convert this 0 to 1 applying the first kind of operation and then convert it to 0. It will take total 2 operations. Else case is s1 of I minus 1 is 1, so it will take 1 operation and you have converted it to 0. Okay, finally also there is also one more case, one more case available. Let's say if you do not have any of neighboring elements, you do not have any element towards right, and also you do not have any element towards left. So what you will do in this case? In this case, if you do not have any neighboring element of an index, in that case you can't convert from 1 to 0. So let's add this base case. If n equals to 1 and s1 of 0 not equals to s1 of 0 not equals to s2 of 0 and s1 of 0 equals to 1. In this case, there is no possible way to convert this 1 to 0. So you will return -1. All other cases are always possible. Now the only remaining cases are where you need to convert 0 to 1. So let's do it. If s1 of I not equals to s2 of I, just increment, because this is the only case where you need to convert 0 to 1 and it takes only one operation, that is first kind of operation. At the end, just return the answer. Okay, so the first sample test case answer is 1. For the second sample test, answer is 3. For the third sample test, your answer is -1. Let's submit it. Great. So let's move to the third problem now. Our third problem is count distinct ways to form target from two strings. You are given three strings: word1, word2 and target. Your task is to count number of ways to form target by choosing characters from word1 and word2 under the following conditions. For each character of target, choose one matching character from either word1 or word2. Okay, the chosen indices from word1 must be strictly increasing, the chosen indices from word2 must be strictly increasing, and you need to select at least one character from both of these strings, word1 and word2. Two ways are considered different if at least one position in the target is either different or either the chosen characters come from different indices or different strings. At the end, you need to return the number of ways to form the target string from using the characters of word1 and word2. Let's see the constraints. Constraints are order of hundreds, so you need to solve this problem. You can solve this problem in n cube, where n is the length of maximum length of any of these strings, right? And maximum length can be 100, so you can solve it in 100 cube, that is 10 to the power 6. So it is possible. So you can solve this problem in, if the lengths are n, m and k, then you can solve this problem in n into m into k time. And this says, and the problem description says that from the problem description itself, it looks like we can solve this problem with the help of dp, right? Because the states are given in such a way that you can always apply dp here. Because let's say for any first of all, let's understand, let's take an example of the first sample test case, right? So you want to find the total number of ways such that you can pick some number of characters from word1, some number of characters from word2, and your total after arranging the picked up characters from both of these strings, the final string formed should be your target string, right? So if you understand this total number of possible cases, what we can do is we can pick the first element from word1, pick the second element, that is in the element at index 1 from second array, second string, and then pick word of 2, 2, matlab third element, means third character of the second string, that is C. So your final string formed is ABC, that is equals to your target. So this is also one of the way. Right. So similarly, you can also see that these are also some other number of possible cases in which your target string is ABC. Total there are 5 number of ways to form the target, right? So here, how are we going to solve this problem? What we will do is we will form a DP array, right? Let's say what we'll do is, let's say this is string s1 and this is string s2, right? And you are given this target string. So what I'm saying is, let's say you create a DP array. Let's say this size of this is n, m and k. So you will create a DP array of size n, m and k. And what does your state DP of I, j? To make it different, let's say the length of the target array is t. Otherwise you will find this confusing. Okay, so what does this DP of I, j, k state store? So your DP of I, j, k will store that the last indices you picked, the last index you picked from string s1 is I, okay, and the last index you pick from s2 is j, and now the number of this is let me define it more in an understandable way. This represents number of ways to form prefix of target array, prefix of target string of length k such that last picked character from s1 is ith and last picked character from s2 is jth. Okay, so this is the state which stores the number of ways to form prefix of target string of prefix of length k from the target string, right? And you have picked the last picked character from string s1 is I, means ith, and the last picked character from s2 is jth. Okay, and this is the DP state. Now you can solve this problem. Now you will say that why do we need to store these two states, that is I and j, right? Why you can't only store the state k? This is required because if we know the last picked index from s1 and last picked index from s2, then we can satisfy these two conditions, that is, the indices picked from both of these strings must be strictly increasing, right? So now, for example, let's say you know that the last picked index from S1 is I, then the number of then the indexes you can pick from index S1 are either I plus 1, I plus 2, I plus 3, or something like this. That is, now you can only pick indices which are greater than I. Similarly, if you know the last picked index from string S2, then you know that the subsequent indices you can pick from S2 are either j plus 1, j plus 2, or up to the length of S2, right? Because you need to maintain this order such that the indices picked from S1 must be strictly increasing, and the indices picked from word 2 must also be strictly increasing. Now, once you know this state, right, the subsequent finding the subsequent states is very easy, right? So let's say how you will find any general state of this DP. Can you find this state DP of JK? You will say that yes, we can find this state. First you will check if, right, we are going to find this state. Okay, so what I will check is, first I will check if S1 of, let's say, if S1 of I if S1, this is the first case where I am checking whether the last character, that is kth of string T, matches into ith character of string S1, right? If this matches with target string K, target of K, then what I will say is I will pick the ith index from S1, right? And now it matches my kth element of target. Now I can pick any of the indices, uh, any of the previous indices from S1 which which might have been required to form the previous prefix. आप नहीं समझे तो मैं क्या कहना चाह रहा हूँ कि हमें इस स्टेट को फाइंड करने के लिए क्या चाहिए. फॉर दिस स्टेट वी नीड टू फॉर्म दिस प्रीफिक्स ऑफ टारगेट. हमें ये प्रीफिक्स फॉर्म करना है. ये स्टेट बस यही कह रही है. और जो लास्ट पिक्ड एलिमेंट्स फ्रॉम S1 है वो होना चाहिए आपका I, एंड द लास्ट पिक्ड एलिमेंट फ्रॉम S2 होना चाहिए, वो J होना चाहिए. तो मैं दो केस लूँगा इधर. दो केस क्या होंगे? या तो मेरी लास्ट पिक्ड एलिमेंट है वो इससे मैच करना चाहिए, वो ये केस हो गया. या मेरा जो लास्ट पिक्ड एलिमेंट है फ्रॉम S2 ये इससे मैच करना चाहिए, राइट? ये दो ही पॉसिबिलिटी हैं, क्योंकि आपका लास्ट इंडेक्स या तो आइदर S1 में से था या आपका S2 में से था, और कोई एक तो मैच करना चाहिए, अदरवाइज तो आप फॉर्म ही नहीं कर पाओगे इस प्रीफिक्स ऑफ दिस स्ट्रिंग को, प्रीफिक्स ऑफ स्ट्रिंग टारगेट को. नाउ इस केस को समझो कि लेट्स से इफ द लास्ट पिक्ड एलिमेंट was from S1 which matches the last element of this prefix. अब आपका काम क्या बच गया कि आपका जो ये प्रीफिक्स है ये इसको फॉर्म करने के लिए भी कुछ नंबर ऑफ वेज होंगे, राइट? सो डीपी ऑफ आई जे के में आप क्या जोड़ दोगे? प्लस इक्वल्स टू टोटल नंबर ऑफ वेज टू फॉर्म this prefix कौन सी प्रीफिक्स? प्रीफिक्स फ्रॉम प्रीफिक्स ऑफ लेंथ k माइनस वन, बिकॉज k तो आपने फॉर्म कर दिया इधर से। k कैसे फॉर्म किया? आपने S1 में से ith इंडेक्स पिक किया, वो आपका k हो गया। अब आपका काम बच गया टोटल नंबर ऑफ वेज टू फॉर्म दिस प्रीफिक्स, राइट। और इस केस में आपका जो लास्ट पिक्ड एलिमेंट फ्रॉम इंडेक्स S1 क्या होना चाहिए? वो होना चाहिए ग्रेटर देन इक्वल्स टू, हम वन बेस्ड इंडिसेस को कंसिडर कर रहे हैं एक बार के लिए, तो आपका वो होना चाहिए 1 से लेकर i के बीच में, राइट। क्योंकि आप हमेशा इंक्रीजिंग में ही पिक कर सकते हो। i आपने अभी पिक कर लिया, तो पिछले लास्ट पिक्ड एलिमेंट क्या क्या हो सकता है? 1 2 3 अप टू i माइनस वन। और लास्ट पिक्ड एलिमेंट फ्रॉम S2 क्या हो सकता है? वो तो ऑफ कोर्स j ही होगा, और कोई पॉसिबिलिटी ही नहीं है, क्योंकि इस स्टेट में ही आपने ले रखा है कि लास्ट पिक्ड जो एलिमेंट था फ्रॉम S2 वो j था, राइट। सो अब तो बस इजी हो गया हमारा काम। समेशन कर दो dp ऑफ i डैश j k माइनस वन, समझ गए? i डैश क्या है? i डैश है आपका, ये i डैश है, i डैश है आपका 1 से लेकर i माइनस वन तक, इसका सम कर दो और वो आप dp ऑफ i j k में ऐड कर दो, सिंपल। अब आते हैं सेकंड केस पर। सेकंड केस है आपका S2 ऑफ j इज इक्वल्स टू t ऑफ k। दिस इज ऑल्सो वेरी सिमिलर। अब आपका लास्ट पिक्ड एलिमेंट फ्रॉम S2 क्या है अभी करंटली? j, कि आपने S2 ऑफ j को इक्वलाइज कर दिया t ऑफ k से। अब आपको t1 टू t k माइनस वन मतलब प्रीफिक्स ऑफ लेंथ k माइनस वन फॉर्म करना है, और उसमें लास्ट पिक्ड एलिमेंट फ्रॉम S2 क्या हो सकता है? वही 1 टू j माइनस वन, क्योंकि j तो आपने पिक किया है अभी अभी, और S1 में से लास्ट पिक्ड एलिमेंट क्या होना चाहिए? i होना चाहिए, क्योंकि वो तो फिक्स ही कर दिया आपने। तो इसके लिए भी सिमिलर हम क्या करेंगे? dp ऑफ i j k में से आप क्या ऐड कर दोगे? प्लस इक्वल्स टू समेशन ऑफ j डैश इक्वल्स टू, इस बार j डैश है वेरिएबल, i क्योंकि फिक्स है, j डैश इक्वल्स टू 1 टू j माइनस वन dp ऑफ i j डैश k माइनस वन, राइट। और ये आपका भी ये स्टेट कैलकुलेट होगी, क्योंकि दो ही पॉसिबल केसेस हैं। तो दिस इज हाउ यू कैन कैलकुलेट योर स्टेट। अब ये आप ये बताओ कि इसकी टाइम कॉम्प्लेक्सिटी क्या होगी इस सॉल्यूशन की? इस सॉल्यूशन की टाइम कॉम्प्लेक्सिटी होगी, हर एक स्टेट कैलकुलेट करने के लिए आपका हो गया n क्यूब। n क्यूब सिंप्लिसिटी के लिए मैं ले रहा हूँ, इनकी लेंथ इक्वल एज्यूम करके चल रहा हूँ, राइट। तो फॉर नाउ लेट्स अज्यूम द लेंथ ऑफ ऑल ऑफ दिस स्ट्रिंग्स आर इक्वल्स टू n। सो इस केस में आपकी हर एक स्टेट कैलकुलेट करने के लिए आपका टाइम कितना लगेगा? n क्यूब। और हर एक स्टेट कैलकुलेट करने के लिए फॉर ए पार्टिकुलर स्टेट टू कैलकुलेट हमें कितना टाइम लग रहा है? लीनियर टाइम। वी आर आइदर इटरेटिंग ओवर आई डैश, और वी आर आइदर इटरेटिंग ओवर जे डैश। सो इट also takes order of n time. So total your time complexity is order of n to the power 4, और n to the power 4 तो नहीं चलेगी इधर, क्योंकि n आपका 100 है, तो मैक्सिमम n क्यूब भी चल सकती है। तो आपको थोड़ा और ऑप्टिमाइज़ करना पड़ेगा। अब आप देखो, ऑप्टिमाइज़ हम कर सकते हैं, क्या कर सकते हैं? इस चीज़ को ऑप्टिमाइज़ कर सकते हैं और इसको भी ऑप्टिमाइज़ कर सकते हैं। हम इधर क्या कर रहे हैं? हम इधर बेसिकली j और k माइनस वन फिक्स है, और i डैश वेरिएबल है, और i डैश क्या है? 1 टू i माइनस वन। तो बेसिकली प्रीफिक्स सम ही कैलकुलेट कर रहे हैं फॉर दिस पार्टिकुलर फिक्स्ड स्टेट। हम प्रीफिक्स सम कैलकुलेट कर रहे हैं फॉर दिस पार्टिकुलर i। सिमिलरली इसमें भी i और k माइनस वन फिक्स हैं, तो आप j डैश पर प्रीफिक्स सम ही कैलकुलेट कर रहे हो फ्रॉम 1 टू j माइनस वन। सो ये चीज़ आप प्री कंप्यूट कर सकते हो, और इससे क्या होगा, आप ये ऑर्डर ऑफ 1 में फाइंड कर लोगे, ये वाली चीज़ ऑर्डर ऑफ 1 में फाइंड कर लोगे, देन आपका सॉल्यूशन कन्वर्ट हो जाएगा ऑर्डर ऑफ n क्यूब में। n क्यूब क्यों, n क्यूब तो आपको एटलीस्ट लगेगा ही, क्योंकि आपको हर एक स्टेट कैलकुलेट करनी है। एट द एंड आपका आंसर क्या होगा, आपका आंसर होगा सम ओवर ऑल ऑफ दीज वैलिड स्टेट्स, वो आपका आंसर हो जाएगा। सो लेट्स ट्राई टू इम्प्लीमेंट इट। इधर हम अच्छा हम स्पेस कॉम्प्लेक्सिटी को भी एनालाइज कर लेते हैं। टोटल स्पेस जो कॉम्प्लेक्सिटी होगी वो होगी आपकी n क्यूब, अगर आप यही सॉल्यूशन यूज़ करते हो तो। अब 10⁶ हो जाएगा टोटल स्पेस आपका, क्योंकि n आपका ऑर्डर ऑफ 100 है। अब इसको भी आप ऑप्टिमाइज़ कर सकते हो। आप क्या कर सकते हो ना, कि आप जैसे ही अब आप हर एक के लिए आप हर एक प्रीफिक्स के लिए टोटल नंबर ऑफ वेज फाइंड कर रहे हो, राइट। लेट्स से आपने के तक के टोटल नंबर ऑफ वेज फाइंड कर लिया, अब k+1 के लिए करोगे तो अब क्या कर रहे हो ना, आपको एक्चुअली ये लास्ट स्टेट है इसकी नीड ही नहीं है, क्योंकि आपको के लिए सिर्फ k-1 का पता होना चाहिए, समझे इधर। वी डोंट केयर अबाउट k-2 k-3, वी ओनली केयर अबाउट k-1। सो हम बस प्रीवियस स्टेट स्टोर कर लेंगे, हमें सारी के लिए सारी प्रीवियस स्टेट स्टोर करने की ज़रूरत नहीं है, बस लास्ट स्टेट हमें पता होनी चाहिए। तो वी कैन जस्ट कीप ए ट्रैक ऑफ स्टेट्स और i, तो इससे हमारा सॉल्यूशन इम्प्रूव हो जाएगा ऑर्डर ऑफ n² में, राइट। सो लेट्स ट्राई टू इम्प्लीमेंट इट। n is the length of word 1, okay, m is the length of word 2, n is the length of word 1. Great. Now let's define the state of this DP n+1 वन बेस्ड इंडेक्सिंग स्टोर करेंगे DP में, राइट। और बेस केस हम ये ले लेंगे कि 0,0 अभी आपको 0 लेंथ की प्रीफिक्स बनाने के लिए टोटल नंबर ऑफ वेज क्या होंगे, ऑफ कोर्स 0,0 लो। 0 का मतलब क्या है, S1 में से 0 लेने का मतलब क्या है कि आपने एम्प्टी लिया है, अभी कोई करेक्टर लिया ही नहीं, लास्ट इंडेक्स 0 है, 0 तो हो ही नहीं सकता ना, क्योंकि 0 तो 1 से पीछे हो गया, मतलब आपने 1 बेस्ड इंडेक्सिंग हम अज्यूम करके चल रहे हैं, तो आपने 0,0 लिया, इसका मतलब हम दोनों स्ट्रिंग्स में से कोई भी करेक्टर अभी पिक नहीं किया है, और दोनों स्ट्रिंग्स में से कोई भी करेक्टर पिक नहीं किया मतलब एम्प्टी है अभी स्ट्रिंग, और एम्प्टी प्रीफिक्स को बनाने का टोटल नंबर ऑफ वेज कितने हो गए 1, मतलब कि कुछ सेलेक्ट ही मत करो। तो ये हमारा बेस केस हो गया। नाउ लेट्स इटरेट ओवर दिस टारगेट, राइट, target string and try to form the prefix one by one, right. first we will find all of these DP states for the prefix of length 1, क्योंकि ये पार्टिकुलर 0 के लिए, प्रीफिक्स 0 के लिए, समझ रहे हो ना। अब हम 1 के लिए फाइंड करेंगे, k=1 के लिए, k क्या है ये वाला, k=1 के लिए सारी स्टेट्स कैलकुलेट करेंगे, देन k=2 के लिए करेंगे, अप टू k=t के लिए करेंगे, t इज़ द लेंथ ऑफ दिस टारगेट, k=t के लिए करेंगे। अब t के लिए हमने कैलकुलेट कर ली सारी स्टेट्स, तो हम एट द एंड सम कर देंगे i, फॉर ओवर ऑल ऑफ i, j। सो नाउ लेट्स find the states one by one for each of the prefix incrementally। इधर हम u क्या है, the last character of the prefix of length I, prefix of length k, right। हमें k से मतलब नहीं है, क्योंकि k को स्टोर ही नहीं कर रहे ना, हमें लास्ट स्टेट से मतलब है बस, और लास्ट करेक्टर हमें पता होना चाहिए, तो लास्ट करेक्टर अभी क्या है u है। ओके, अभी क्या सारी स्टेट्स कैलकुलेट कर लो। इससे पहले आप एक चीज़ और कैलकुलेट कर लो, ये प्रीफिक्स भी कैलकुलेट कर लो, प्रीफिक्स सम। ये जो प्रीफिक्स सम ऑर्डर ऑफ वन में हमें फाइंड करना है, तो इन सारी स्टेट्स के लिए प्रीफिक्स सम कैलकुलेट कर लो। सो व्हाट वी विल डू इज, एक तो हमें न्यू डीपी चाहिएगा। इसमें न्यू डीपी क्या है? न्यू डीपी आपका है आप करंट डीपी स्टेट स्टोर करने के लिए, आप इसको करंट डीपी स्टेट भी बोल सकते हो, करंट डीपी स्टेट या न्यू एनडीपी बोल दिया मैंने सिंपलिसिटी के लिए, छोटा नाम रखने के लिए। So for shorter naming, I just picked NDP. NDP means it will store the current states, means the states for this current prefix. Okay. और आप prefix sum कैलकुलेट करने के लिए दो स्टेट और ले लो, राइट, एंड JDP इक्वल्स टू DP। ये क्या है? IDP क्या स्टोर करेगा? प्रीफिक्स सम ओवर ऑल ऑफ द कॉलम्स। आई में आपका आई फिक्स रहेगा, मतलब रो फिक्स रहेगी, और आप कॉलम के लिए प्रीफिक्स सम कैलकुलेट करोगे। JDP क्या है? JDP में आप कॉलम को फिक्स रखोगे और रो के लिए प्रीफिक्स सम कैलकुलेट करोगे, क्योंकि आपको इसमें एक ही चीज़ वेरिएबल है ना, या तो जे है, कॉलम के लिए प्रीफिक्स सम फाइंड करो या रो के लिए प्रीफिक्स सम फाइंड करो। ओके, अब हम कर लेते हैं, प्रीफिक्स सम फाइंड करते हैं सबसे पहले तो। इफ I is greater than 0, ए प्रीफिक्स सम फाइंड कर रहे हैं, तो इफ I is greater than 0 देन IDP का I क्योंकि फिक्स है, ये होगा आपका JDP ऑफ IJ हो जाएगा। इस केस में क्या है, आपका J फिक्स है, मतलब कॉलम फिक्स है, आप रो के लिए प्रीफिक्स सम फाइंड कर रहे हो, तो JDP ऑफ I माइनस 1 कोमा J। अब आप फाइंड करोगे, आई फिक्स है मतलब रो फिक्स है, आप कॉलम के लिए फाइंड करोगे। IDP ऑफ I माइनस आई कोमा J माइनस 1, है ना। ये I क्या मतलब बेसिकली ग्रेटर देन 0 के लिए, क्योंकि I माइनस आई अगर ऑलरेडी 0 होगा तो ये आउट ऑफ बाउंड चला जाएगा ना। तो सिमिलर थिंग है, J ग्रेटर देन 0, ये कंडीशन लगाने की भी ज़रूरत नहीं थी, क्योंकि अगर J 0 होता तो ये कंडीशन फॉल्स हो जाती। C++ में ये ऑलरेडी इन बिल्ट है, बट no worries, we have just written the full condition. If I is greater than 0, then we will calculate this prefix sum over fixed J. If J is greater than 0, then we will calculate the prefix sum over fixed I. So once we have the prefix sum for fixed column and fixed row, now let's calculate all of the states of this current, right? Current prefix of target के लिए हम सारी स्टेट्स फाइंड करते हैं, तो हमें NDP ऑफ I कोमा J फाइंड करना है। सो फर्स्ट ऑफ ऑल वी विल चेक इफ I इज ग्रेटर देन 0 एंड S1 ऑफ I माइनस 1 मीन्स ये जो ith इंडेक्स है ये S1 में मैच कर रहा है U से। U क्या है? लास्ट एलिमेंट ऑफ द प्रीफिक्स फ्रॉम टारगेट। अगर ये ith एलिमेंट फ्रॉम S1 मैच कर रहा है U से, इन दिस केस हम क्या करेंगे, NDP ऑफ IJ क्या होगा, यही होगा, यही वाला केस। S1 ऑफ I ये मैच कर रहा है अगर T ऑफ K, करंटली हमने U लिया है, अगर ये S1 में से कोई इंडेक्स मैच कर रहा है तो हम ये वाला प्रीफिक्स सम ऐड कर देंगे हमारी स्टेट में। प्रीफिक्स सम ओवर क्या है आपका J कांस्टेंट है, NDP ऑफ IJ प्लस DP ऑफ IJ, राइट। I-1 तक ही आप कैलकुलेट करोगे, क्योंकि 1 to I-1। अब आता है सेकंड केस, वेयर योर S2 of J इज इक्वल्स टू लास्ट एलिमेंट ऑफ योर प्रीफिक्स। सेकंड केस क्या है? सेकंड केस है आपका J is greater than 0 and S2 of J minus 1 is equals to your last element of your prefix of target array. If this is the case, then again we will update our NDP of IJ. This is current state. इसको कैसे अपडेट करेंगे? इन दिस केस हमारा I फिक्स्ड है और J वेरिएबल है, क्योंकि J के लिए प्रीफिक्स फाइंड करना है हमें। तो IDP ऑफ I, J माइनस 1 to J माइनस 1 क्यों किया? क्योंकि हमें 1 to J माइनस 1 से ही मतलब है। ग्रेट। नाउ okay, once we have all of these states ready for our final target array, अब हम क्या करेंगे? हमारा आंसर क्या होगा? हमारा आंसर होगा सम और ऑल ऑफ these states, राइट? इस सारी स्टेट्स का, क्योंकि हम लास्ट पिक्ड एलिमेंट क्या हो सकता है हमारा? कोई भी हो सकता है ना। लास्ट पिक्ड एलिमेंट लेट्स से हमने S1 में से I पिक किया, S2 में से J पिक किया, और इससे हमारी फाइनल टारगेट जो स्ट्रिंग है वो बन गई। और इसके लिए टोटल नंबर ऑफ वेज कितने थे? उसके लिए टोटल नंबर ऑफ वेज आपके थे DP of IJ। रिटर्न योर आंसर। also create this variable mode. There is one another thing, इधर आपने करंट स्टेट, अब करंट स्टेट कैलकुलेट तो कर ली इस लूप में, अब असाइन भी कर दो DP से, राइट? दिस इज इट, सो लेट्स रन इट। इधर हमने 1 से क्यों स्टार्ट किया? हमने 0 से क्यों नहीं स्टार्ट किया? क्योंकि क्वेश्चन में दे रखा है कि हमें एटलीस्ट 1 एलिमेंट पिक करना है वर्ड 1 और वर्ड 2 से। तो हमारा लास्ट एलिमेंट 0 नहीं हो सकता, लास्ट इंडेक्स 0 नहीं हो सकता। 0 का मतलब है हमने कोई एलिमेंट पिक ही नहीं किया S1 में से। सो दैट्स वाई वी आर स्टार्टिंग फ्रॉम 1। लेट्स रन इट। S1, ओ हमने हर एक जगह S1 ही लिया है क्या इसको? दिस शुड बी word 1, and let's also replace S2 with word 2. For first sample test case answer is 5, okay. For second sample test case answer is 4. For third sample test case answer is 2. For fourth sample test case answer is 1. Great, so let's submit it. Integer overflow, इधर मोड भी लेना है। Great. So now we have solved all of these 4 problems. I hope you are able to understand these solutions. If you have any doubts or if you have any query, you may ask in the comments. I will reply. So let's meet you in the next video. Until then, have a nice day. Thank you.